Hello everyone and welcome to my channel. In this video I'm going to speak about different area types in OSPF network. And before doing that, I want to speak about why you would go for creating an extra area in your network. Is it not okay to have just one big flat OSPF area 0 and put all the routers in that? As a matter of fact, it is, and most of the time you are encouraged to do that. So you say that you have, I don't know, whatever number of routers you have in your network, you put all of them in one big giant OSPF area. So let's say that this is going to be OSPF area 0, which is the backbone, and you have, let's say, hundreds of routers in here, and all of them are connected to each other and they're working just fine without any problem. So why would you just give up on this kind of network design and go and create different types of areas? One of the most important one is going to be the size of the database. So size of the database is going to be one of the deciding factor. Why? Because when the size of the database grows exponentially, then routers are not going to have enough resources to process this and run SPF on such a big database. The other thing is going to be the number of networks. So when you have a huge number of networks, that's going to mean the size of the database is going to start growing. So this one is going to result in the first one. So whenever you have such a huge amount of networks in your in your OSPF network, then what you need to do is to just give up on that and put some of them in another area. And the third one, which is going to be the least important one, but yet you might consider it as a deciding factor, is going to be the legacy devices. What I mean by that is when the amount of database grows, when the size of the database grows, the newer router have no problem working with that. Newer router have something like 32 gigabytes of RAM, 64 gigabytes of RAM, and a Xeon processor that is very powerful and can just, can run SPF and in a second just receive the result of the SPF algorithm. So that's going to create a database very fast. But the old legacy devices do not have such amount of RAM or such a powerful CPUs. So what we need to do is to just make sure that these devices are not going to be part of big areas. So this is going to tell us that we need to put them in a small areas. So when we put them in a small areas, what happens is we have a very small database in that area, and also we can just configure to send and receive only a few routes, maybe just the default route into this area, so that these devices are not going to be overwhelmed with the size of the database. So let's just say that, okay, in my case, I'm going to create an area. So what are different area types that I can create in this environment? So let's say that this is my area 0, and in my area 0 I have a number of routers, and I have decided that I need to have another area. So what I'm going to do is to put some routers in that area, and let's say this area is very beautiful, like this rainbow area, and then what I need to do is to have a router in between. This router is going to be kind of a, let's say, just one or multiple routers in here. This router is going to have interfaces in area 0 and interface in area, let's say, number 1, or whatever number that you are going to give to this. Let's say area 1 is this one. So this means that having multiple interfaces in multiple areas causes this one to be considered as an area border router, a rainbow one, of course, in this case. An area border router, which is created with just putting some interfaces in one and some interfaces in another area. Now, the thing is, this area border router should be a little stronger than other routers. Why? Because it has a database for area 0 and another database for this new area, whatever the number is going to be. So it needs to have a little more resources than a normal router in your network, because it has two different databases, and also it is going to run two different SPFs, each for one of these areas. So that's going to make it a little more overwhelmed with the amount of processing and with the amount of RAM that we need to allocate to this. So this causes this just makes us think again on what type of areas we really need to have in this case, so that these areas are going to have the least impact in the design of our network. Or maybe the type of area that we are going to create is going to say what kind of problem we are trying to solve. Sometimes we say, like I said, some of the devices, some of the deciding factors that I just spoke about is having legacy devices. These legacy devices have another problem, that you might really want to put them in a separate area. So this is going to be flapping networks, having problematic interfaces, and anytime one of these happen and a router has a flapping interface, then this is going to send a notification to other routers that this interface is unstable, or maybe this network is available. Now this network is not available. Others are going to, make some changes, maybe by running a partial SPF, and then they're going to renew their database with the updated information. So that is going to, make us think about the type of area that we are going to have and how we are going to decide which routers are going to be put in this area. So let's do this. We are going to have 4 different types of areas, other than the backbone area, of course. We can have, well, let's say 5 different types of areas. One of them is going to be a normal area. In a normal area, we have routers here. Let's say 1 router, 2 routers, 3 routers, and they are connected to each other, and they share the same database. Also, ABR, of course, shares the database with them. And they have all types of LSAs, let's say LSA type 1 and type 2. And of course, because we have an ABR here, then we are going to have an LSA type 3. This LSA type 3 is going to send some information from this area into here, which means that we are going to have information about the networks on the other area. So normal areas, like any other area, a normal area as a matter of fact. So it has all types of LSAs, 1, 2, 3. If we have, let's say, a router here which is adjacent with a non-OSPF network, or an OSPF network with a different domain ID, then this is going to make this, let's say, this is going to make this an ASPR, area, or let's say autonomous system border router. And autonomous system border routers, as a matter of fact, are points of redistributions. So we call this area autonomous system border router. So autonomous system border routers are points of redistribution. So that is the role that we can have here. Can we have autonomous system border routers here? Of course we can. So we can have ASPRs connected to area 0, ASPRs connected to other areas. So one of the types of the networks that is going to be normal can have ASPRs. Let's say, for example, this one is an EAGRP network, or OSPF is another domain ID, or BGP, or whatever. Then we can have LSA type 5 here. The other type of network that we can have, the other type of area that we can have is going to be a stub network. So a stub network is going to have LSA type 3 because it is going to receive some summary LSAs from area 0 through this ABR. But the thing is, this is going to receive default route as well as summary information from other areas. So that default route is going to be used to reach to other networks which are connected to backbone area. So most of the time we can easily just default to that default route, and we can just say, okay, we do not really need other LSAs, so why not just remove all of them? And in this case, of course, this is going to be very much relevant. You can see that I have only one ABR here. This means that any route that I'm going to take, I need to go through this ABR to get to that route. So why would I really go for different information from other areas? I can have just one default route, and that's going to be enough for me. This means that I can just go with something which is called totally stub area. So a totally stub area doesn't have any LSA type 3. The only thing that it has is a default route which is injected here by the ABR, and it says anywhere that you want to reach out to, just go through me, and I am okay with that. In case we have multiple ABRs, of course, that would be better to go with the stub area, but we can, of course, define two default routes on each one of the ABRs. One of the default routes are going to be advertised, and then let's say that the most preferable ABR is going to have higher priority or a better administrative distance, and that's going to be used. In case that fails, the other ABR is going to take over. So let's say that we have an adjacent domain, like an OSPF domain, which is different from our domain, or like an EIGRP, BGP, RIP network that is here, and we have a point of redistribution. In this case, stub areas cannot really be used because the stub areas are not supposed to have redistribution enabled on them. What we want to do here is going to be using NSSA, not so stubby area. Let's say that we are merging with another company, and that company can be connected to one of our other areas. So that in that case, this is going to be a very good scenario to use a not so stubby area. A not so stubby area allows redistribution. This means that we can have LSA type 3, summary information from other areas, and we can have LSA type 5, which is the redistributed routes into our network. And that LSA type 5, of course, would be advertised to other areas as well. Now let's say that, again, our NSSA network area type, or this one, has only one ABR. And in that case, again, I would say, okay, now that I have only one ABR, why would I go with different information about reachability to other networks? I would easily default to a default route and use that. And of course, I have LSA type 5, which I'm going to advertise to others. So I'm going to go with NSSA, totally NSSA, let's say. So that would be totally NSSA. Totally NSSA is going to have only one default route from this ABR. In case we have multiple ABRs, two ABRs, of course, we cannot really go beyond two. We can have multiple ABRs, more than two, but that would be not good. The highest number of ABRs recommended is going to be two. One is just a single point of failure. Two is very good, but more than two is going to be problem. So that would be good. And these two can just advertise their default routes here. One of them is going to have a higher administrative distance. The other one is going to be more preferred. In case that fails, the other one is going to take over. So you see that having multiple area types makes sense in a lot of scenarios. But most of the time, again, what I'm trying to tell you is you should not really go with creating multiple areas just because you have a big number of routers. So if, for example, someone asks you how many routers you can put in just one flat area, there is no special number for that. You say, for example, I have seen networks with 800 routers in just one area, but the thing is, they are resourceful. If they lack enough resources, then you need to put them in multiple areas. This is one of the reasons. If the size of database grows very much, then you need to create multiple areas. If you have part of a network that is flapping and has problem most of the time with legacy devices, of course this happens, then you need to create multiple areas. And of course there are some other design expectations that push you to create multiple areas, but one area is the way to go in the beginning, and that area should be area 0. And then in case you need to create multiple areas, then you would go with one of the types that I just introduced to you: normal, stub, totally stub, NSSA, or totally NSSA. Which one is better? I would say totally NSSA or totally stub. These two are going to be the best ones because they are going to have the least amount of pressure on the router and the least amount of, let's say, troubleshooting problems, specifically when a route is inaccessible, whatever it is, and you try to just kind of create a connection to that. So that would be it, and I hope you can visit other videos. I hope to see you in other videos, and